Owen mentioned, this represents what's known as the 80-20 principle. So this is also known as the Pareto Principle. It's sometimes referred to as what's called the law of the few. Sometimes it's called the Matthew Principle. So it has a number of names, and essentially what it means is roughly, at a high level, the relationship between inputs and outputs isn't balanced. So roughly, a minority of the inputs produce majority of the outputs. So what this means is the way you see this sort of play out in the world is that you see it, for example, in the distribution of wealth. So, for example, if you take like the top, like richest people in the world, they collectively have like hundreds of billions of dollars of wealth, and you compare that to like the average person who has almost nothing. So it's hardly a comparison. So a very small minority of people, they have like majority of the wealth, and the remaining majority of people have very little in comparison. And you see this in like companies. So like the top richest companies have like trillions of dollars in wealth, and if you compare that to the remainder of companies, they have hardly nothing in comparison. It's certainly true in the transmission of virus. So a very small number of people actually transmit a virus. So they're the people who go out a lot, or they come in contact with a lot of people, and they're the ones who end up spreading a virus and sort of make it tip. It's also true in like the productivity of workers in an organization. So I saw this a lot throughout my internships and my past experiences. So the last company I worked at was roughly like something like 65,000 people or something. And maybe half of them were like engineers, and so maybe like 30,000 engineers. And that's a lot of engineers working on a lot of different projects. So there's people working on the mobile app, people working on the web page, people working on particular a settings page, and but all those things really, they don't add a lot of business value in the overall picture, right? But there's select projects and very certain projects that add a lot of value to the company. They're the projects that generate like billions of dollars. So out of like that 30,000 engineers, maybe like 5% or less than something like that, a very small number of people are actually the ones who are leading the very large company initiatives. They're the ones who are building the large scale distributed systems that power the website under the hood, or they're the ones that design the large scale storage systems that let you retrieve and store lots of data, or they're the ones that are designing very complex APIs and libraries used across the whole company. And so those are really the projects that generate a lot of business value for the company and also revenue. And it's a very small number of people out of all of the engineers that actually produce all of that output. So it's a very interesting concept, and you see this like almost everywhere. It's almost like a natural law, and you even see this on like social media. So if you've ever noticed that most of the content you see, well, most of the time you're actually consuming content. You're not actually the one that's writing a particular meme or posting it for people to see. You're the one that's actually consuming it. So it's an interesting sort of idea, and again, it's almost like a natural law. And in statistics, it's actually modeled by like an inverse power law. So it's actually a function that decreases exponentially, and essentially it gives rise to that idea of the 80-20 principle, where roughly a very small number of people control majority of the outputs. And the reason I bring this up is it has applications in software testing. So, it's not a hard and fast rule. So it's a general rule of thumb, 20-80. But the actual sort of breakdown could be like 90-10 or 95-5. The point is that it's a minority of factors that affect the majority of outcomes. And so this is true in software testing. So I've seen this time and time again in the projects that I've worked on, in the internships that I've done, that a very small number, generally speaking, a small number of, a small portion of the code and very small and specific bugs actually produce majority of the, they produce majority of the outcomes. They make majority of the test cases fail. So for example, I was working at the startup last year, or almost 2 years ago now, and I was testing sort of this core algorithm that I wrote as part of like this overall system, and that algorithm was relatively small component of the whole system, but it was an important component. And maybe it was like a couple, it was maybe like 50 or 60, 70 lines out of like thousands of lines. But there was a lot of tests, obviously. But I realized that there was a flaw in that algorithm, and a lot of the tests were failing. Almost all of them were failing. And when I dug deeper, it turned out that a very specific bug in that particular algorithm in a very specific part of the code was causing like majority. It was making almost all of the test cases fail. So a very small and specific bug in a very small and tiny portion of the code was causing a lot of problems. So it's an interesting concept and something to keep in mind. And it's a good rule of thumb to follow when you're writing your tests for an application, is that focus on the very specific and small bits of your application that are the most complex parts. They're usually a small fraction of the whole program. But you should focus on testing that rather than exhaustively testing every single thing. And I think Dr. Page probably touched on this in lecture, is that testing isn't about testing every single thing. It's about gaining enough confidence. And the way you gain sufficient confidence in your program is by testing the roughly 20% that represent the most important bits of your program. So anyways, it's an important, I know I find this pretty interesting. So, and it relates to software testing in all sorts of different domains. Anyways,